All right, linear systems of equations, two variables. Example 2. Once again, there would be graphs that would be related to these. Two variables, both variables are to the first power. Somewhere on some graph paper out there, there would be a line that would represent perfectly straight like that one, a line that would represent that top green equation. Similarly, two variables, it's got a graph. They're both variables are to the first power, and that would also graph out as a line. Now keep in mind, not every graph is a line, but in this case, they are. And we're looking for the ordered pair, the point that would solve both, which is physically the point of intersection. All right? So we're looking for that ordered pair where they cross each other. And as we established on example 1, watch these in order, please. On example 1, graphing is not the best way to do it because your lines have to be perfectly straight and you have to have really good eyesight. So, here's the thing though. So we just talked about graphing in general. Substitution requires that we have a variable by itself. I'll remind you in example 1, we had y equals. Now, if we wanted, we could get a variable by itself in one of these equations and then do substitution. But most people would tell you, myself included, that a better approach for this particular one would be something called elimination, which means you're going to get rid of one of the variables. I always make the point to people that it doesn't matter whether you decide to eliminate x or eliminate y. It doesn't matter. It's a coin flip. So we're going to flip a coin. Let's see, I'm looking for a coin here. I'm sorry, my endorsement contract with Texas Instruments hasn't come through yet. I'm having a little trouble finding a coin. Would one of you perhaps be able to loan me a coin? I'm really embarrassed. I'm really sorry here, but anybody got it? Oh, you got one? Okay, here. Okay, thank you. Oh boy, what a big spender you are. All right, so you're gonna give me a penny. Well, it's a start. So anyway, we're gonna flip this penny. Let's just say if it's heads, we're gonna eliminate x, and tails, it's gonna eliminate y, and I hope you'll trust me. So heads is x, tails is y. All right, flip, it's hitting the ground, you can't see it. I promise, I swear, I'm looking down, and it says tails, okay? It says tails. Okay, so we're gonna get rid of y, okay? So here's the deal. What we need to establish is what's called the least common multiple. You'll get the idea. The point is, if you look at the coefficients of y, you're looking for the smallest number that would go, that both 8 and 6 would go into. Another way of saying it is, what's the smallest number you could build them both up to? Another way of saying it would be, if you had fractions with 6 and 8 on the bottom, what would be the lowest common denominator? And if you think about it a little bit, the smallest number that these both go into is 24. And the point is, we're going to build them both up to 24. All right? Build them both up. Multiple. 6 goes into 24, and so does 8. All right? So we're going to build them both up to 24. It's just like getting a common denominator for fractions that have 6 and 8 on the bottom. And so you look at that top one, and you say, well, how do you change a 6 into a 24? You multiply by 4. And if you do it to the top one, or if you do it to the left, you do it to the right. So on that top equation, we shall distribute a 4 through there, and that equation transforms into 16x plus 24y equals 88. All right. So again, keep in mind that the penny that we flipped said, get rid of y. Thanks so much for the penny. Wow. Get rid of y. And so we're focusing on y. Now here's the deal. If that top equation became positive 24y, we want the bottom one to become negative 24y. See, think ahead. Positive 24y and negative 24y are going to get rid of each other. They're going to eliminate each other. So, that's positive 24y. What do we need to do to the bottom equation to make it become negative 24y? Well, we better multiply that bottom one by negative 3. on both sides. So, that equation then becomes, make sure you distribute it to every term on both sides, negative 18x, negative 24y, and what's 28 times negative 3? My brain hurts. Is that negative 84? I hope I'm right. Let me double check my arithmetic there. Yes. Negative 60 and 24, yeah, okay. Now look, we have like terms lined up. We have like terms lined up. I drew a line under here to indicate that we're going to combine the like terms in the two. We got the x's lined up, we got the y's lined up, we got the numbers lined up. Combine like terms. Combine like terms. Add the two equations to each other. This is negative 2x. Look at that, y went away. I know, what's another word for went away? Eliminated. We got rid of y. And then 88 minus 84 is 4. Now we're down to one variable. We go ahead and solve it out for x. And it turns out that x would equal negative 2. And then you come over here and go, well, that's the x-coordinate of that point we're looking for, right? But we're not graphing them and using our eyeballs. And again, what if that was some crazy decimal? Okay, so x is negative 2. I still like the picture, even though graphing isn't the most accurate way to solve these. It still helps you visualize the question because it helps us understand that we still need to find the value of y. And you would hopefully look back here and go, okay, I can put negative 2 in for x in either one of these equations. Again, I think it's probably a coin flip on which one, top one, bottom one, doesn't matter. So flip a coin again, all right, flip the penny that you gave me. Let's suppose it says to come back and put that in for x in this bottom equation here. See, the point is once you start to get numbers, you can substitute them backwards into your equations and go find the other variable. So if x is negative 2, 6 times negative 2, plus 8y equals 28, solve, 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 one variable. That would be negative 12 plus 8y equals 28. Add the 12 over. You gotta keep them separated. And so 8y would equal 40. Divide by 8, divide, divide. And y turns out to equal 5. And then you come over here and you put 5 in there, and that would be the point where these two lines cross each other. The ordered pair, negative 2, 5. Our answer is that ordered pair there that I've circled. So, anyway, that's elimination. And I hope that made sense to you, as always. So, elimination, elimination. I don't know if you can hear that. Anyway, I'm sure that's you guys, I was at a concert by that band, Overkill, and they played Elimination. There you go.